So we've talked about lots of different types of landslides and some of the causes for the specific ones, but we're going to look a little bit more generally at landslides completely. So, what causes landslides? Well, there's a few specific causes, but one of the biggest effects is how steep your slope is, the shape of your terrain. Is it flat? Are there lots of valleys? Your soil type, what's in there, how thick is it, the underlying geology. So that means the types of rocks, along with their porosities and permeabilities, how they respond to different things like stress. Do they fold? Do they break? And again, like layers, and how are they tilted and moving? Are they faulted? There's a lot going on there. And then, of course, the people. What kind of structures, what have we done to that shape of the landscape over time that ends up affecting it? All right, so this is a list of really common physical causes that end up triggering a volcano or a landslide. And usually when I say a trigger, it's a transient event, something that happens that finally, boop, there goes the slope that was already unstable in the first place. So like a whole lot of rainfall all of a sudden, or lots of precipitation over a longer period of time, or rapid snowmelt, or it could be rapid drawdown or filling of water. That sentence doesn't make any sense. I'm sorry. I copied it from somewhere else. But really fast changes in water in terms of surface water and groundwater, or earthquakes, or volcanoes, or freeze thaw, or shrink swell. There are clay minerals that when they get wet, they swell up and they shrink when they dry. They also get really slippery when they get wet, or flooding over an area. So why water is so important? Well, water's heavy. It's about 8 pounds per gallon, and that can put a lot of stress on a slope, since gravity is one of the main drivers of these landslides happening. It lowers cohesion. Think about building a sandcastle. Dry sand doesn't build a sandcastle very well. You need it a little bit wet. And when it's a little bit wet, the sand grains stick together. That's called cohesion. But if you put it too much water in there, the water actually gets between the sand grains. And when they're between the sand grains can't touch and they start moving. And we've talked about that in terms of liquefaction before. And clays get really slippery when they get wet. I mentioned that before. If you've ever done any pottery, worked on a pottery wheel, you got to keep that wet to keep it nice and slippery. Well, it's because you're using clay, and clays are a natural thing. Water also expands as it freezes. And so that expansion opens up cracks and it induces more instability. But water can also cause flooding. Kind of as a result of a landslide afterwards. All right, so other causes here. So things that are going to end up weakening a slope, not necessarily causing the landslide, but giving us the right conditions for landslides to happen. So weak materials, like volcanic slopes or marine sediments, weathered materials, jointed or fissured materials. We talked about jointed volcanic or sandstone rocks. Adversely oriented mass discontinuity. I love that. Bedding planes. So you tilt it over, and that could be just because of the layers themselves. It could be a result of metamorphic processes. Or you've got some sort of structural discontinuity, a fault, a nonconformity, a contact. In those cases, your rocks can change really quickly. In particular, that permeability we talked about, or the stiffness, that kind of comes back to the lateral spreads. Or there could just be bigger things going. So tectonic processes uplifting glaciers. Once all the glaciers melted, they weren't pushing down on the crust anymore. And so now the crust itself is rising back up, particularly like in Canada. And that causes tilting. It causes changes in groundwater. It causes changes in slope. Fluvial erosion, wave erosion, just water taking off this toe of a slope, or people taking off the toe of a slope, but that's not exactly natural. And vegetation removal, those are those forest fires or droughts, although humans do it too, thanks to logging. So humans can excavate the slope. We do that a lot to put in roads. We can use unstable fill for construction, a bunch of loose materials that are prone to moving in the first place. We could put a whole lot of stuff at the very top of a slope, like you want a nice view, so you put your house up there. We can create reservoirs, like building the Three Gorges Dam and filling it up with a whole lot of water. When we talked about flooding, I mentioned how the reservoir has led to a lot of extra landslides in the area. We cut down trees, put in unstable roads, irrigation. And what's sort of interesting is the lab that you're going to be working on is all on a landslide in California. And it's being blamed on loading slope with unstable fill and or irrigation or septic tanks adding too much water to a slope, which is sort of interesting. Mining, we saw the mining in Washington is leading to a landslide happening, or artificial vibrations like we saw in the Amazon, or water leakage from utilities or sewer lines, or just messing with rivers and moving them where they aren't supposed to be. So human activity is kind of interesting. And these are triggers for non-seismic landslide events. And so for the most part, these are human caused. And you can see construction and illegal mining and other mining pretty much accounts for nearly 75% of all landslides that weren't caused by an earthquake. And that's a lot. So here's an example that kind of takes all this into account. There was a landslide in 1963 on the Vajont Dam. So this occurred in Italy. What you can see is there's a really narrow canyon in the mountains, and they put a dam across it. At the time, it was the largest or maybe tallest like arch type dam in the entire world. So they dammed the river, and you can see there is a reservoir filling up back behind it in the picture on the right. So these are all before pictures to give you kind of another idea here of what this looks like. You have a big valley down here at the bottom, U-shaped valley. This is created by glaciers. And then there is another little valley leading into it where the dam is, and you can see where all these towns are around here. So if we kind of look at a cross section here of what it looks like, there's a couple of pretty nasty things going on. You can see there are rock layers that are tilted down towards the valley. You also have a layer of clay, and darn tootin' if that's not where the failure plane is. And you also have water flow under there. So the water is actually flowing just beneath that clay from the aquifer. So the groundwater is flowing, adding moisture under there. But as the reservoir starts filling up, it starts messing with that groundwater. So there's all sorts of things changing all at once. In 1960, there was a small landslide, and they got kind of worried. So they lowered and raised the reservoir level a few times, but then they just rose and rose and rose and rose, and then the failure itself happened in 1963. Now, this was a kind of a combination of a lot of rain and not a lot of water let out of the reservoir. So you can see in these graphs at the top you have precipitation. The second one down, you have reservoir level, and you can see where a couple of landslides happened, and after the November slide, they were like, oh no, we should probably take this down. They made a little tunnel to kind of release some water, and then went full bonanza on filling that thing up. And you can see that the catastrophic slide that happened in October was sort of at the peak of terrible here. Along with the rate of motion, you can see the rate of motion pretty much goes right along with the reservoir level, unfortunately. So these are some shots from 1960. So in October, they started recognizing that there's, oh, look, some pretty nasty little cracks happening at the top of the slope. And on November 4th, that catastrophically failed. But the good news is it was fairly small, but it did fill in part of the reservoir, and they got a little worried. That's when they started doing a lot of kind of big changes. And then at 10:39 p.m. on October 9th, 1963, there was a large landslide into the reservoir, and that's what you see here. The entire mass of landslide material slid approximately 500 meters north at up to 30 meters per second, and it completely blocked the gorge to a depth of up to 400 meters. It then splashed up the other side, and you can see that, 140 meters up the opposite bank. Sorry for all the meters, but it's Italy, so that's what they measured in. It took about 45 seconds for this to happen. But when that massive landslide hit the lake, the reservoir, it created what was basically a tsunami that was pushed up the opposite bank. It destroyed the village of Casso that was 260 meters above the lake level. So they were quite a bit higher than the lake and got taken completely out by the tsunami. And then that tsunami wave overtopped the dam by 245 meters. An estimated 300 million cubic meters of water then fell 500 meters down that valley and into that large glacial valley below and completely destroyed the villages of Longarone, Pirigo, Villanova, Rivalta, and Fay, and completely decimated and wiped them out. It's estimated that the tsunami displaced the air. So the water wave coming over the dam, it displaced air with a force supposedly more powerful than the atomic bomb dropped on Hiroshima. The victims were found with their clothes completely blown off. Their skin was damaged and internal organs were ravaged by the force of the blast. And that means a lot of times that's the lungs. It'll completely blow up your lungs when you're hit by that air pressure. A total of 2,500 lives were lost, leading this to be one of the deadliest events in Europe history. And this is a shot of some of the people who were able to escape. Unfortunately, because it happened at 10:39 p.m., you had a lot of people who were asleep and had absolutely no warning in this case. This is what it looks like now. The dam is still there. The dam was actually not damaged too much. It's still standing. But you can see the landslide. You can see where that town has sort of been rebuilt up on the side here that was completely wiped out. But obviously all they're doing is letting water flow through it at this point, and they're not specifically creating a reservoir behind the dam anymore. Here's another example of a landslide that was quite a few factors all added up. Palu, Indonesia had an earthquake in 2018. This actually created quite a few landslides. And this is a little time lapse of the ground just oozing down. This is actually not too much faster than real time. I know when we talked about tsunamis, I showed this video. So this earthquake caused some major liquefaction, and the whole town, large parts of the town literally just floated down. So it looks like those houses are like floating on water, but it's dirt. It's the soil that was that underwent liquefaction because of the earthquake. Now, unfortunately, some of these landslides ended up going into the bay at Palu, and it created a tsunami that also killed people. So this was a combination of all the worst things in the world, unfortunately. Here's another earthquake caused landslide. This happened just outside of Christchurch, New Zealand, in 2011. Christchurch had experienced two earthquakes, one in 2010, which was actually a larger magnitude but further away, and another one in early 2011. And while the magnitude was lower, it was much closer to town. And it caused a lot of damage. As you can see, this house looks fine, right? Except it's sitting right below that big old cliff. And that big old cliff just lodged a big old rock that actually bounced here. You can see where it bounced. And then went through the roof of the house. And there it is, sitting in the garage. And that's lovely. So earthquakes are a major cause of landslides. Here's another kind of interesting earthquake thing. During the 1994 Northridge earthquake, landslides within the mountains above the Simi Valley had created lots of dust. And that's what that picture is there from the Santa Susana Mountains. And what they found is that dust carried spores of the fungus that causes valley fever. Now we have valley fever here, and even though we refer to the area here as the Phoenix Valley, or just the valley, it's actually named after the San Joaquin Valley in California, where there is a whole lot of valley fever. And if you remember, we talked about the San Joaquin Valley when we talked about subsidence and groundwater. But what they found was in the Simi Valley, which was just downwind from these mountains, that the cases of valley fever actually went up something like 16 times higher than normal in the weeks and months following the earthquake. It actually led to quite a few more deaths than normal. So probably 20 people, I think is the number I saw, died because of valley fever as a result of the Northridge earthquake.